Thanks everybody for showing up. Nice. It has a cinema atmosphere, right? Sit back, relax, try not to fall asleep. And have some popcorn. It's going to be a fun movie. Yeah, continuous delivery. It's one of my most passionate topics. I really like it a lot, and I'm really invested in making that whole thing work ever since I had to log onto machines to put some code there and just take some jar that I produced and manually S-copy it, and everything went to flames and everything was bad. Ever since then, I dreamed about having something like this, and just 10 years of a career later, I'm finally at a place where we do this, and I'm really excited, and I want to share. I want to share the joy and the fun I have with that. So first of all, my name's Chris. Thanks for showing up. I'm from Munich. That's why my English accent is terrible, and I have no Russian speaking capabilities. I work for Mathmatch, which is a material search platform. It's if you need some tungsten, if you need some molybdenum or maybe some uranium, then it's a good place to go. And we're a developing team of 5 and me running around there and trying to do something very cool. And yeah, we're a tiny little startup, if you will, from that size. But this talk should show what you can do with a tiny amount of people if you're just dedicated and believe on something. And to start out, what I hear a lot is, I'm working in a startup, I've been consulting startups a lot before. You hear that runway metaphor a lot. And I have my issues with the runway metaphor, right? It makes sense from a financial point of view. It basically says, you're a startup, you have that long to go, and you either lift off or you crash, which is theoretically right. But I don't think it tells the whole picture, because a runway is straight, and all you need to do is go full throttle and know how to do that plane thingy, and then you will lift off. And I think that just goes too short, right? A startup world is way more complicated. And so what I think is more appropriate is the downhill metaphor, because sometimes you should really take a left. And because these guys were very good at getting speed, and nobody was hurt, but like nobody's injured. But if you follow the video for longer, you see even more people flying into the bushes. It's just one more time for you. Yeah, so. Yeah, it's a release or a relief from your business capabilities. I guess that nobody was hurt, but just some egos were bruised. I think as a business, the ability to adjust quickly is very important. It's almost fundamental, right? In the startup I'm working in, we're 1.5 years in, and we've pivoted twice, and it's still not the very best thing to do. Right? If we would have gone with the original plan, we would be where this guy is in the bushes. And I really like working at Mathmatch, so I want to keep working at Mathmatch, which means the company should probably be successful enough to employ me. And that's one of the drivers why I go for that whole continuous delivery and continuous deployment thingy, because I want to be employed and I want to make that business really healthy. And in the startup world, I think building the wrong thing or being too slow, both are big cases for dying as a company. And I think our duty to the businesses that employ us and pay us and keep us fed, it's our duty to help them to get the ideas out there as fast as possible, as fast as we can do it. And there are ways to do it, right? If you think about how we usually develop software, or how I developed software in a lot of cases, is that somebody somewhen had a really great idea. And then that idea went into the backlog to die, or just to be there for a really long time until it doesn't make sense anymore, right? And then eventually it gets picked up and it goes into that magical box called development, and then magic happens and the engineering people do it, And then once you have developed it, there's another cold dead storage that's called waiting for release, because you have something and now it sits there for weeks and for months until it can go out, until it eventually can go to the users, right? I've been doing consulting for banks where the release train said 6 months, and you would do something really wonderful or something nice for the software you're building there, and then it would be stuck there for 6 months. It was terrible. It's one of the reasons why German banks are so terrible, because they can't innovate at all, right? The innovations we get, we should have had in the 90s. Well, I hope it's better in Belarus. No, sorry. So in the best cases, what if we can add, I can't do much about this thing at the moment, but about this thing I can do something, and if I can kill this part off and I get my thing, whatever I built, to the user faster, I get feedback faster, and probably will also have better ideas what to do with our product in the future. So in that long loop of despair, at least getting rid of one of the boxes makes the process more enjoyable. So one interesting question that I keep having with my engineers when I ask her, what does done mean? And is it done, or is it done? Or is it really done, or is it the donest? And then that's just for engineers, right? We in our group have a lot of different opinions on what done means. And then there's maybe a product owner who has a complete different idea of what done means. And then there's my CEO who has also maybe an idea of what done means. And finally, in the end, there's these picky things called customers who are out there, and they also have their idea of what done means for when you're building something, right? If you make nice announcements, at some point it's the customer to decide if they like it or not. So, because I like to make up things, here I make up a quote. For me, done means live and available to the customer, and everything before it's just an excuse, right? If your tests pass, that's nice, but it's not bringing value. If it's deployed on a staging system, that's also nice, but it's still not making money for your company. So in the end, it's a job of software to go out there. And for this, we have that whole suite of continuous thingies, right? All these continuous buzzwords. And let's wrap it out. The continuous integration, the delivery, and the deployment part of that concept. So if you want to start up, the first thing, I did that for quite some time, I guess, since I joined development 8 years ago. That was kind of a common thing, right? You would not just build software on your laptop, you would give it somewhere to some piece of software that would build it, and if you're lucky, it would execute the tests if you had written any. And then, then you would know, okay, I did something, and my colleague did something, and somebody else did something, and it still all makes sense together. It's a potentially releasable thing. And it's pretty cool, but that just means it's potentially releasable, and most of them don't see the light of the day. They just get built, and they stay in the Jenkins build cache for 6 months, and then somebody cleans them up. There's not much value that they really had in the meantime. So the next ideation step you could make around that is to continuously deliver things. And now that's where the scary part comes, because how could you just release anything right into production? That's scary to a lot of people. It was scary to me at first. So what the concept of continuous delivery says is that you could, but you don't have to, right? You have everything in place. You might want to run some acceptance testing on the whole thing you have. You have a big scary button that you can push, and then it goes to production. It gets deployed. And maybe, if you're really lucky, you have some smoke tests afterwards that make sure that your whole thing is still running. But this is the fantastic safeguard. You have one button or one thing you can click, and then you have also one single ringable neck of who clicked the button that you can punish. So that gives you a way to build the full automation thing and make sure that it's replicable and always works all the time without going into that scary territory. And once you're fine enough with this, you take the button away and you have continuous deployment. So as soon as you commit something to your repository, it gets built, it gets tested, gets through the acceptance test, gets out to the production, and then maybe some other test that make sure that it's still up there. So that's, at least from my view, the idea of continuous deployment. So, and just classic. Just a few days or just 2 weeks ago, I found that tweet from, I guess also retweeted from Charity Majors, but she tweets so much that I can't find it anymore. But it was about some people don't deploy on Fridays. And I think if you have such a rule in your company, that's a very obvious anti-pattern sticking out. Because if you don't deploy on Fridays, you already know something is wrong. And instead of fixing it, you decide not to do things. And it's usually not helping, right? You know the whole idea of if it hurts, you probably should do it more often. So we had that at the beginning, and I very quickly got rid of it. And I'm very happy because for some reasons, the engineers on my team, everything gets done on Fridays. I don't know why, but Monday to Thursday they build, and Friday it's ready by magic. Don't know, but it would be really bad if we didn't deploy it then. Also some important wording we need to clarify is, what do you really want to optimize for? There's these two concepts going on, mean time between failures or mean time to recovery. Mean time between failures is the classical guilt-driven, blame-driven approach. So you do something and it goes wrong. So what you do is you first blame the person and punish them. And secondly, you make sure it doesn't happen again. So you put on a lot of safeguards, you make sure the time between now and the next failure is as long as possible. And so both of these concepts comes from manufacturing industry and such. They've been around for a while. And they discover it, and then software had to rediscover it again because we don't believe anybody. We have to figure it out ourselves. The opposite idea would be the mean time to recovery. So where you think things will probably go wrong. It's kind of a sure thing in software development. So what I want to make sure is that when something goes wrong, I want to be as fast as possible to restore my service or to restore availability of what I have. And coincidentally, these two things are always against each other. If you optimize for one thing, you break the other, and vice versa. If you look for a lot of safety things to make sure no failure happens, it will take a long time to recover because you have all these safety things that you need to work through. And vice versa, but we'll get to it, why it's more interesting to optimize for mean time to recovery. So that's a nice tweetable slide is, errors will happen. Errors do happen all the time. At least when I'm involved in software, a lot of errors will happen. And what I've learned is the worst things I did were when something was already wrong and some people were breathing down my neck and I tried to fix it. That's where I would make the biggest mess, right? That's when you delete production. That's when you mess up your routing. That's when everything really goes awful. So I think in a situation where errors happen, and they do, you want to do the exact same thing that's proven and tested and true when you do your regular releases, right? No shortcuts. If you have to leave something out in your release process when it's urgent, you probably should leave it out all the time, because when it's urgent, that's when it's the most important. So I think if you have a good pipeline that brings your stuff from the beginning to the end, and it's fast and reliable, then you are in a good state to recover your stuff. And then you can also be more brave and more daring about the things you do, because you can't just fix them forward. So, and then there's the state of DevOps report, right? I'm a manager, so I learned by pain how to talk to other managers, and these kind of things help. So if you want to sell the whole concept, this is pretty cool. It's also the State of DevOps report is closely aligned to the Accelerate book that I'll recommend afterwards. It's a pretty awesome thing, a lot of science behind it, so you can trust these people, don't trust me, they know what they're doing. They correlate a couple of things. First, they separate companies into release or delivery performance. So for example, the high elite performers, they deploy more often than every hour. And the high ones, once a day, once every hour, once every day. And then once a week to once a month, and also once a week to once a month. So you can kind of group your companies. Who's in the elite group? Hi?
Not in this audience.
Not in this audience? Not yet? You? Cool. The rest, you have some catching up to do. Because it is interesting that also the lead time, like how long does it take me to get something done, if it really needs to get done, it correlates. So you can get something done really quickly if you have to. And now the catcher is, you usually think if you deploy to production all the time, things are on fire all the time. But actually they are not. The time to recovery, of course, goes down, right? It's the same thing. But your change failure rate, so the rate, how often things go wrong, it goes down by a lot. So in the end, you are safer if you do it all the time. Proven by real science, not just some jerk. And if you kind of look at your total time on error, like how often is your system really broken, if you deploy all the time, it will be less broken over the year than if you only release every once in a while. The reason behind that is mostly if you are here, your releases are very big and you have no idea what they are. And the more you go over here, your releases are tiny and you know exactly what they are. And you have all the interactions proven or the coincidences. And also that's a thing to convince managers why you should do continuous deployment. The time you can spend on what, right? Developers are super expensive, so you want to make sure that they do something for their money. And if you're in the elite group, you can spend the most of your time on actual new features, things that make money. The other people have to spend way more time on reworking things they did, that does not make you money, on fixing security issues, on fixing defects, and on supporting your customers. So you have more time to actually build useful things. Also, if you spend less time on support, means your customers are more happy and will probably give you more money.
People spending 10% of their time in the pub, because it's not.
You have to ask the authors of the DevOps report what they left it up. But I imagine I do. Yeah, it's self-support then too. Good. Good meaning. I'm from Munich, so we're more in the beer garden than in the pub, but it's the same thing. So now, small little demo. I want you to go to demo.mathmatch.com. You can use the QR code on your cell phone. And I've provided something. So first I'll let you photograph it before we look at it ourselves. And it's an application with a rather obvious design mistake. I tried to boil it down to this. So for people who don't have cell phones, it looked like this, and you have the options to spend money, yes or no. And as developers, I kind of made the no button really big because no one specified how it is. Now comes the part where you can ruin it completely. I set up some Google Analytics, and so you can break it. But I think people are overwhelmingly trying to not spend money. Now the idea is, what if I could, well, how hard is it for me to change that thing and to preview it? Because I have some slide about that afterwards, that most of our issues were not in the bug part of releasing software, they were in the review part or the finding out what people really wanted or what they really need. So what we have built for Mathmatch is that's the live version, and I already prepared something, prepared a merge request for I want to change something. Now I have to go there. Let's say somebody says a great story, make button bigger. That's the quality you usually get from your product owners, right? So let's see, it comes the part with the live coding. And don't mind the chaotic part of the code. What is going on here? I want to edit it, but it doesn't let me. No, deleting is really bad now. Let's not do this. So here we have, since I wrote it, it's the highest quality of code you can have. And I still can't edit it. Nice. It's not that I tested it a few minutes ago. Oh, if I click on edit, I can edit. Who would have thought? So let's take this part here and this part over there.
Is copy-paste strategy?
Yes, copy-paste driven development is great. Also, commit messages are very important for other people. So what happens now? And now, of course, I have to. I try to mix it down to the most simple project I could make that still has some looks like something. But what's now happening is a pipeline will go live. Will start to run. And what it does, it builds the whole thing, and it also publishes it. It does not just build it and test it. It doesn't test it because I deleted it for speed's sake. That's what you do. It will, at some point, deploy it to some URL that some other person can view. And this is, for Mathmatch, this has been a great revolution. It's, if you think about it, it's not that super technical special, but the notion that we could review the things we were building early was super important to us, because we spend a lot of time building the wrong thing, and then the product people said, what's that? I don't need that. Or our CEO told me, that's not what I want. Or customers ignored it, all of that. So with faster feedback, we get way better, way higher quality of reviews. Let's go over to the presentation for a bit, for 1 more minute, because until the whole pipeline runs, because I can already start to tell you how we got there. Because like I told you, we deploy things to branches, and as soon as you merge it, it gets moved to production. That means we usually have a merge rule of two approvals that we need, 2 groups. One is a developer, that means we do code reviews, and other developers like the code that the developer wrote. If I wrote it, I get a lot of comments and a lot of suggestions to grab it. And the second review group are the business people, or the reviewers, the product owner, if you will. They also take a look at the merge request, and if they like how the visuals are or how the functionality is, they also approve. If both things get approved, it goes out to production, and you can share the blame then. So that's what we have. Let's see how that little thing is progressing. So now, if I did the right thing, yes, I have a fantastic feature, and I can show this to my product owner that this might look better. And you notice, for you, the users out there, it's still the old broken way, but internally we can think about if this is the right thing to do. And if we are, In this case, I'll just merge it all alone because nobody wants to work on a weekend here. And now if you keep going to this page after the pipeline has finished and deployed it, it should be live on Mathmatch. And then hopefully our analytics should improve over time and we get more people buying things. And this is, of course, it's a sample project, but it's the exact same behavior that we use on Mathmatch. So I could do a code change to my production code base with the exact same thing. And I would be very sure that I can release the thing because we have in that, for the production stuff, we have all the tests, all the security. I know it's going to work. So keep clicking that thing and we'll spend some more time on how we got there. Because when I came and when we started Mathmatch, of course, there was not much, and all we had was high ideals and high ideas, but it started rather classical. So into what we had to do to get from a standard software setup to our continuous deployment, I'll just try to work you through it. So first was fix the deployment automation, all the little bits and pieces you have to automate to make the thing work. Second, fix testing, because we had bad tests, intermingled tests that didn't make any sense, so we had to clean that up. Third one, which I just showed you, is fix the review process. That was even more important than fixing the testing, because we were having a lot of useless things released. Number 4 was fix observability. Like if you release to production all the time, you need to make sure you know what's going on. You need to be really invested in your production systems. You can't just mark tickets as done and be done with it. So that whole DevOpsy mindset is really important if you want to go that way. Then fixing the release process itself to make sure it's really stable, it's really reproducible, there are no ugly bits and pieces anymore. Took us a lot of refactoring. And the last and most important thing and the hardest to do was fixing fear, because people were afraid of what's going to happen. And let's see how we got there. Like in the beginning, we had make. It's a Spring Boot Java application. We still had make. Don't judge me. It happened. It's a fine thing. But we had that make script where you can say deploy production, and it didn't work, but after a while, that's all you had to do to deploy our monolith to production. And after we split some parts out, all of them had a make thingy, but you have to get there. If you want to automate the whole, or if you want to have these pipelines, first you need the automation. You need to have something that with one command execution, it deploys to production. Like all these automating pieces that need to happen. The second one was a bit more tedious, fixing our testing, because that's like a rough sketch of how a testing pyramid could look like, and ours, it looked like a lamppost, right? Because there was no tests at all. So what we had to do is first untangle unit and integration tests to separate them in different build steps, and get fast feedback on the unit level, because our integration tests are halfway slow. And it also goes back to the fear topic. We needed a few, and I really say a few end-to-end tests, and we're really happy with them. We had to get the business to define what the value streams of our applications are. Like, what's the thing that needs to be running so we can make money? For example, for Mathmatch, that's the search, or users signing in, or somebody publishing something. For some platforms, changing your avatar is not super mission critical, but displaying a list of tweets might be super critical. Finding that out, and only for the most terrible important things we have end-to-end tests. Because otherwise that stuff goes out of control. You have that inverse pyramid and it runs for 3 days and you can't do it anymore. So we still believe in the pyramid-shaped test pyramid. There's other people that might rightfully disagree. For us, that works pretty well. So yeah, splitting all that apart and making good sense out of it and seeing where you lack on testing was an important part of our journey. So, and then build speed. That was a very interesting anecdote we have. So when we started, we went with Travis, which is a pretty cool product. Unfortunately, our tests were slow, and a lot of them, and there was no way to give them money for bigger machines. I tried really hard, waving my credit card at them, and they say, nope, this is how we think testing works. You have one machine, this is it, have fun. So, didn't work for us, so we went over then to AWS Code Build, which is pretty cool because you can just spin up machines for your build and then destroy them afterwards. So you can use kind of big machines because they will not live for very long. You don't have to pay that much. And then in the end, when we finally moved over completely to GitLab and their pipeline, where GitLab has that concept of runners, so they also spawn some machine to run the tests. And the cool thing is it integrates with spot instances, which are cheap, unreliably. They can terminate at any minute, but they are cheap, so we could get just the biggest things we could, right? It doesn't matter if they just live for a few minutes and they're spot instances, you can go pretty quick. So we went as far as that speed up our build. That was pretty nice. And yeah, what I showed you before, if we looked at what really went wrong in our release process in the half year that we did, and we found out that broken code was rarely the issue. In the most times, it was we built the wrong thing, or it was not exactly how I wanted it, right? And we usually had these arguments of, yeah, that's not what you wanted, but that's what you specified. And that's why we built it this way. Yes, but it's not what I wanted. And it gets you nowhere, right? You can't. I mean, I'm German. I'm very good at being right, but I'm also it's also usually not very helpful. We tried to then fix just the review process that I showed you before. So if you want to look at that by now, yes, we have a beautiful big button now. And hopefully, you got a bit slow over time, but hopefully I'm getting rich now with my changed application. So that's, I can. Hmm?
Is there a slide?
It is live, yes. It is live. The button is now big, and I'm going to be rich with my big button. Yeah, I cannot emphasize it enough how important that was for the company culture, because you are not operating in a vacuum. So we also had to demo then a lot, because we, as engineers, you like to forget all the things that you do, and keeping regular demos helped us a lot to keep track of what was really released, because no one's going to read release notes. We had to fix something about our environment, right? We run Kubernetes because we can, and it's cool and it's fun, but getting all that bits and pieces and strings working took us some time. And before you can do really continuous deployment or just continuous delivery, you want to have all that stuff worked out, because if you stress it, it will break more. So it broke for us, but now we have it kind of under control, and it's pretty nice. Big important thing is observability of the system. I'm very keen on that. That most of the developers that joined my company, they were not really used to interact with production systems. They were used to write good code, write good tests for that, commit it, get it reviewed, and then forget about it. And at a small startup, that doesn't fly. We don't have any operators. We don't have any manual testers, and there's only one person on call, and that's me, 24/7. So if stuff breaks over the weekend, I come back grumpy, and nobody wants that. So we did a lot to emphasize for people how important it is that software is not just built, but also it has to be running to make an impact. So we What we use for us is, of course, Elastic Stack for doing centralized logging, doing a lot of dashboards, aggregation, just to see how the whole thing goes. We use Datadog a lot, where I can recommend it. It's pretty nice. And it also integrates very well with OpsGenie, which is then the thing, if something goes wrong in our system, it will call me until I pick up and until I fix it. So the whole idea is that you need to be really knowledgeable about your production system. Is it fast? Is it stable? What kind of errors is it throwing? I've been to companies where when you wanted to debug something, you wouldn't really be able to see in the forest of stack traces and exceptions that were flying. You could not really see what was even wrong because 90% of that was, they're okay. And yeah, we try to really limit ourselves to not have exceptions in the log all the time, or actually none at all. And if there is some exception, we actually act on it. Because otherwise you just get lost in the forest of all the problems your software might be bubbling up. One interesting concept that I saw at another company and introduced is the cops of the day, to get people to become invested in production. That means we build a daily checklist, like a pre-flight checklist. Every morning you go through the aggregated logs, were there any errors, go through the latencies of yesterday, all of the kind of things you learn over time, what makes your system tick. You put it in a checklist. It takes us probably 5 to 10 minutes every morning if there's nothing to investigate. And every morning a random pair of developers gets assigned to do that. And if they don't, I'm going to be angry at them. And it helps a lot because, well, as always, in pair programming or pair debugging, you learn from the other person. So after a while, the whole knowledge spreads in the team, and even my front-end React developers know how to jumpstart something if it's wrong. And that's awesome, because we're not that many people, and I need everybody on hand to be able to fix stuff. Also, what helps us getting a feel for our production system is using some chat ops ideas. Not so much changing things on the system via chat, but we are really informed, like when somebody signs up, when somebody posts a message, when a node comes up and down, when a deployment happens. All these things is a continuous stream in our Slack channel. So you get a feeling for how your system ticks. And if it stops ticking, you get concerned. And you're continuously reminded that something is out there that needs to live. Then fixing the release process, there's a couple of things you can do. First of all, we introduced rolling releases. Everything is running on multiple instances, so you can replace things one at a time without going down. Because if you deploy 10 times a day, you don't want to have small downtimes 10 times a day, right? It should all be rolling and being fluent. To also test some things, we started with shadow releases, which means there is some service running, serving production, some other service, we just deploy it, but it's not hooked up yet. It's just there, existing. Sometimes existing is hard enough. Not seeing any traffic, but we can maybe manually connect to it, just see how it goes. And we keep building this thing up until it's ready, and then we switch over the traffic. With for example, Nginx, this is a really easy thing to do. For completeness, you could also do canary releases, which is a bit more than rolling releases. You would release your new piece of software, and you would give it part of the traffic, but you stop, you give it some traffic, and you wait. Right? Like the canary bird in the mine, if it dies because of lack of oxygen, you would see if this thing emits more errors than these things. If it does, you stop. If it's at least as good, you keep continuing. So you can build some manual safeguards in. What we also do a lot is write-based releases. So we have twice the code in our code base, one old logic, one new logic, and there's a role-based switch. And if you have the unfortunate pleasure to be working for Mathmatch, you get the new stuff, everybody else sees the old stuff. So we can really dog food our own stuff until we really feel that it's ready. And then also to limit fear, we started the whole thing with some irrelevant, or not irrelevant, but less relevant service. Right? All of that was click to deploy in the beginning, but this small service, we just deployed it all the time because it was rendering PDFs or getting data from Google Analytics, not so important. And this guy was auto-deployed, the other ones were not. And then, in the end, to limit fear, you have to make it boring. That's what we did. So we automated everything until we had the deploy button. So we were at the continuous delivery stage. Then we made pushing the button boring, and at some point we made it bothersome. Right? I just waited always for the product guy to come. Hey, it's ready. Why can't I see it? Yeah, you have to push the button. Next time he came. Yeah, it's ready, but why? You have to push the button. Please push the button. Please. No. Button pushing. At some time, he was really annoyed with pushing that button. So we removed it. And he was happy. We removed the button and nobody cared anymore. So what I mean is you have to ease yourself into this. And of course, now we're there, now it's fun, now it's awesome, but of course a lot of things went wrong along the way. We deployed to Kubernetes, so of course you need to not just to do Kubernetes, you need to learn Helm. And Helm, learning that was, it sounds like a non-issue, but for us it was not. Until I still hate Go templating. Sorry if somebody is working on it, but I really don't like it. But for us, it took us a long time to learn that. Health and readiness endpoints. Everybody knows what that is? Everybody's using health readiness endpoints? We always get them wrong, always. Like health, okay, yeah, sometimes we get them right. Readiness, never. It's really, really tricky to get them right. Pod limits. First, in the beginning, we had nothing. We just deployed everything without limits, and then it crashed the cluster because it was being too greedy. Then we introduced very strict limits, and nothing got deployed anymore because the cluster refused. And so it took us a long time to really pinpoint our resource limits. If everything goes automatic, it has to be really right because there's nobody to save you. What also happens with these branch deployments that I showed you, twice already we destroyed our Kubernetes cluster beyond recognition. It was just unsalvageable. So we had to rebuild the whole cluster. We were out of ideas. Whenever you would kill a node, replace it with a new one, it would get infected by the mess, and it was all a downway spiral. So yeah, still nervous about that. There's in DNS or in HTTP, if you work with that, with certificates, there are no multi-level wildcard certificates. So we have mapmatch.com, so we could have branch.mapmatch.com as a wild level certificate. That's good. But we also have batch.mapmatch.com, so we would need batch.branch.mapmatch.com, and that doesn't work. And so we were struggling a long time with that. And of course, if you go microservices, it's not so easy to get them right. And one of my colleagues a while ago, she pointed that out, that we actually built a stateful set by accident, and she's very right about this. You can't, at least for Mathmatch, you can't deploy things in a random order. There's still that monolith that needs to come in first. It's not super tangled, but we are not perfect there yet. We have improved since then. But yeah, it's very easy to get that wrong, and then with continuous deployment, it will bite you a bit harder. And yeah, one thing I keep having problems with is fixing logic in a lot of places. So for the deployment description, which is a YAML file, of course, where it describes all of the deployment, we have to copy-paste it over to all the projects. And just recently, I tried to refactor it, and I failed. It's really hard to extract that kind of logic. There's a few small scripts in there that deal with our certain environment, and this one, I haven't fixed it yet. So in summary, what I say, if you go continuous deployment, architectural and operations problem, they bite you twice as fast and twice as hard. They surface earlier. But I think that's a good thing. You know way more about the issues of your architecture before they get a real problem. So it's annoying, but it's very cool. And the rest, you just have to work it off, piece by piece. Like I said, it's now just a few minutes conference talk, but it was months of continuous small little work along the way, right? We never stopped completely, and I would not advise anybody to stop what they're doing and implement that for 4 weeks, because then you have 4 weeks of no features and angry people. So we just, as we went along, we piece by piece went there until we finally had it. So yeah, I still have the duplicate code in a couple of places. That's annoying me, and every once in a while these feature deployments fail to clean up and the cluster fills up. Probably just some bad thing in some scripts. But now we are here. We are faster than we've ever been before. Like really, we can get a lot done. I'm always surprised. I don't have just amazing engineers in my team, but with these tools on their hand, they can really be awesome. We have way less defects and issues, right? Mathmatch is super stable. For how much we release and how much we try, very little thing breaks. And we have a heart for production. I love that I got that into the team. And when it's really getting heated, we can go up to 15 releases a day with 5 and a quarter. The quarter is me, humans. That is only half is because my size, the other half because of my role. But yeah, I'm super happy to being there, and I would recommend everybody to go the same way because it's joyful, and I don't want to work any other way anymore. So key takeaways would be it pays off big time. It's annoying to get there, but it's really worth it. But you should go slow and steady. Don't make a big bang out of it, because you will fail a couple times along the road, and if the stakes are high, it will be annoying. It's also emotions, not just tech, right? It's about fear. It's about taking people on your journey. And don't mess too much with your production Kubernetes cluster. We still have a staging cluster just for all of that play thingies. And yeah, most of the things you have to fix to get to continuous deployment, you would have to fix them anyway. They just surface. And if you want to read more, of course, continuous delivery from Jess Humble. Accelerate is the science behind why all of that is really bringing you business value. Release It is a great book. And The Phoenix Project is a very fun novel to read on a rainy Sunday. All the slides will be published, so you can just click on the links. Yeah. Oh, time for questions. This will bring you to my GitHub with the PDF. And otherwise, I'd be happy to have some questions from you. Wow, thank you. Thank you.
Thank you. So earlier on, so you've mentioned Accelerate. I'm pleased to see you've got that there. Is there one of the 24 key competencies that's called out at the end of that book that help us towards high performance is trunk-based development? But apparently you're not doing that. So I wonder, have you got good reasons for not taking that on? What's your experience of it?
Yes. Finally, someone asked that as the first question. I love that. No, so we thought about it, but the previewing things that I showed kind of makes a branch necessary if you don't make everything behind feature toggles. That would be the other option. Now, our branches live for roughly 24 hours. So the benefit of trunk-based development is lower than month-long branches. And the effort of switching over and the benefits are not very clear to me at the moment. Right? If I'm in a multi-week branch situation, fully clear, I go to trunk-based. How it works here is the benefits do not outweigh the effort to get there. And I still love the discussions we have on code reviews on a merge request. I like to see the whole thing as a complete feature, and the discussions we emerge right now, I would need to find a way to get that. But
so my second question was going to be, do you pair on your development? Because I question what value you'd get from a code review if you've already shared the context through pairing and pair rotation.
Yes, we do pair, but occasionally sounds too little, but we don't pair all the time. My people have, like how they feel is they like to pair a couple of hours a day at most, and they really like some quiet focus time and some quiet focus time to review things. They just value it more to having that thinking time alone. And sometimes they pair, sometimes they don't. It also depends a lot on personality. So, and I think for trunk-based development, you need full pairing because otherwise it does not work. And if your people don't want to do full pairing 8 hours a day, no. Let's not go down this way. So, yeah.
You have very frequent releases, and you said you do not maintain any release notes or some sort of. How do you keep track on what is going on, what is happening?
We get it from the issue tracker in GitLab. Most of our stuff is organized in issues and in epics. Everything that's worthwhile to mention usually lands up in an epic. And we can review, like we can drill down back from that on the things we did.
So did you get it right that the primary source for this is the change log in GitLab?
I mean, since we usually squash all our branches, we have our Git log is pretty small, right? Mm-hmm. Well, up to 15.
So it more or less corresponds to the features released.
Mm-hmm. Yes.
Uh-huh. And the second question about the some defect tracking system. Do you use something for this? And what?
Can you explain again?
Bug tracking system.
We use also GitLab as the bug tracker, where feature and bugs are both tracked as issues. So it also ends up as a commit message if you fix it.
Mm-hmm. Okay, thanks.
Can you pass it to the front? Yes. It's better for everybody, I guess, to really hear it.
Yeah. First of all, thank you for amazing presentation. I have a bunch of questions. So first, most of them will be in testing domain. So did you face a situation when developer kind of does functional part of the development but says, I don't have time for unit testing, and how you resolve that?
Physical violence?
Okay.
No, the thing is, I hold people accountable for what they do. I give great freedom, but you have great responsibility. So whatever you release or whatever you get merged, it goes to production. I'm not going to stop it. And if it breaks in production, I'm going to come to you. I'm going to come after you. So this natural threat is, and then people, oh, but I'm scared. And yeah, write tests and then you won't be scared.
Okay, and what's the relation between amount of unit tests, integration tests, and end-to-end tests at the moment in your project?
Very few end-to-end tests, medium amount of integration tests, and high amount of unit tests in the backend. The front end is a bit more integration test heavy. Mm-hmm. So a house on the front end and the pyramid on the back end.
Okay, and do you have any kind of Scrum iterations or anything, or you just work in lean, like doing work in small pieces, few hours, and release it right away? Or
it's pretty Kanban style if you want to. I got rid of that. I got rid of that idea pretty quickly if I told people they had to wait 2 weeks for something, and then that whole Scrum thing was off the table. No, that Kanban style of working works very well for us.
And do you run some post-mortem analysis or retros or no?
Well, we run the retros
often?
Every 2 weeks.
Okay.
From the team, and postmortems as they happen. And that's also a pretty cool thing to document them and make some valid action plan. Like every postmortem should have a corresponding issue then in your code base, because you have to fix something, right? Something broke, so you have to improve something. And then you can also frame the postmortem as not a blame thing, but okay, this is the mess, how do we fix it now? And that's it. I guess we're cut off, but I'm around all day on the conference. Happy to talk to everybody. So thank you.